David Smith here with one more flipped classroom math video lesson. 3 tips before we start. First, you can adjust the playback speed faster or slower as you desire. Second, you can pause the video at any point to catch up with notes or write down some questions. Third, you can turn on the captions and read my words on the screen. Today's lesson is a review of all the stuff we did in our bivariate data chapter. Now, bivariate, just to review, means data that has 2 variables. So we're looking for correlations between one variable and the other. And we did a lot of stuff with this, and a lot of it was on your calculator. So you want to be sure that you can use your graphing display calculator to do these problems. And remember that on the weekly planner, there are links to click steps for the TI-84 and the Inspire, and links to calculator instruction videos as well. So you'll want to pull up those documents if you're a little rusty using your calculator. So let's get started. So we started by talking about correlation. And I want to remind you that correlation is not causation. All we know is that 2 variables change together. They have some relationship, but we don't know if one causes the other. That's a whole nother topic. So we don't go there in this class. We just measure correlation and talk about it. So we started by making scatter plots of our data, something like this, where we had X values and Y values, and we just put a data point on a graph like that. And we can put that in a calculator as well and learn some things about it. But first, all we did is scatter plots. Now we talked about the correlation strength, direction, and whether or not it's linear. So this correlation is probably moderate to strong. I'm not using a calculator, I'm just looking at it. Moderate to strong. It's linear because it looks like it kind of makes a line, and it's positive because it's sloping up. So that's just one example of how you might interpret a scatter plot. Moving along, we use the calculator to find the Pearson product moment correlation coefficient. Now, that's a mouthful. So we really just call it R. R is the variable that's assigned to this 5-word term. The thing you need to know is that on the test, you might be prompted to find this. And you're going to need to know that they're asking you for R. So using the calculator to find R allows us to discuss these same 3 things, but now we're doing it in a more numerical level rather than a qualitative level by just looking at the scatter plot. So we have strength, direction, and linearity. So strength, now we have some definite ranges depending on the value of R. So for a positive correlation between 0 and 0.25 values for R, we have a very weak correlation. Then from 0.25 to 0.5, it's weak. From 0.5 to 0.75, it's moderate. And then finally from 0.75 to 1, it's strong. And it works the same way in the negative direction. So these would be positive correlations, linear, and depending on your R value, you're going to be able to give it the correct modifier. If your R is negative, it just works the same, but in the negative direction with a negative correlation. The next thing we did is we did some predictions, and we made some prediction lines in 2 ways. First way was a real manual method. So what we had is you'll get a table of data with your X and Y values, and what you're going to need to do is make a best fit line by eye. So this is a non-calculator problem. And so what we do is we find the mean point, which is X bar, Y bar, which is just X bar is the average of all the X values, Y bar is the average of all the Y values. And then we want to add the mean point to the scatter plot. So we've got a scatter plot with all our data points. We throw the mean point on there as well, and you want to mark it as the mean point, so that's obvious. Then we use this scatter plot with the mean point to draw a best fit line. And you'll remember that the best fit line has to go through the mean point and then be drawn as best you can so that half the data is above it and half the data is below it. And we did a little bit more detail on that in the lesson video, so if you want to go back and review that, please do. Finally, then we can use that best fit line either on the scatter plot or the equation to find Y values given X values. So that's where this prediction comes in. I can say, well, what if X is this value? What is Y likely to be given our relationship? The second way we use prediction lines was fully in the calculator. So instead of doing a scatter plot and the best fit line by eye, we put all of our data in the calculator, and then we can use the GDC, the graphing display calculator, to find the equation. Pressing through the menus and the buttons, it will give us the gradient, which is usually denoted by the letter M, and the y-intercept, which is usually the letter B. And that'll give you your equation. You can write that down right from your calculator. While you're in there, you also want to grab your R value. Because if that's a low number, then your confidence about making predictions based on this correlation is not really high. You want to have a moderate to a strong correlation. Finally, we've done those first two things. Either we made our regression equation manually or we used our calculator to do that. Now the final outcome is that we want to use this to make predictions. And so there's some conditions necessary for us to do that. The first one is we need a strong correlation to make a prediction. No moderates, no weaks, no very weaks. It's got to be a strong correlation. Secondly, to predict a y value, you must use a y on x regression. You can't use an x on y. Finally, it must be an interpolation, not an extrapolation. So these are big $10 words in statistics. I want you to pause the video and think about that and maybe draw a scatter plot that would illustrate that. All right, let's take a look at data interpolation versus extrapolation. Here's a scatter plot. So I have my data points in blue and I've drawn my regression line in red. And we're going to say this is a strong negative correlation because we're sloping downward. And the thing is that you can only make predictions that are within the range of your data. So let's check that out. Like our data starts and stops there and starts and stops there. Actually, let's just fix that a little bit right there. So our data is only going to let us make predictions in this range. Because if I make a prediction based on an x value of this one, I don't have any data that supports that prediction. So really, in a way, our regression line only works for here to here. So that's really what our data supports. So I can only make predictions based on the range between x1 and x2 and y1 and y2. So if I have some value out here for x and I want to plug that in and make a prediction about y, can't do that. I can only make my predictions based on these x values, and I can only have results based on those y values. So that's the difference between interpolation and extrapolation. Let's do a few examples to put to work some of the stuff we learned in this chapter. So here's a typical paper 1 type IB problem, so no calculator. So a data set has the following regression line, y equals minus 3.25x plus 4. So there's our regression line. If the mean of x, which is x bar, if that's 10, find the mean of y. So I want you to pause the video, think about that. If you figure out how to do it, it's pretty quick and straightforward. So using this equation to find the mean of y, you just plug the mean of x into the equation and it's going to give you the mean of y. So here's my plug-in step. I did my math and I got my mean of y bar is minus 28.5. Okay, a little more practice with your calculator. So here's a data set. There's no scenario here, it's just x and y values. What I want you to do is use your calculator to find the regression equation for y on x. So pause the video, pull out your calculator, do all the steps, put it in there, and come back. All right, so here's what I get out of my calculator. I did my 3 sig figs, and there's my regression equation. I also noted my R, and you can see we have a strong correlation, so that's good for making prediction. One last question. Here we go. In order to use the y on x regression equation, this must be true. A has to be less than or equal to y, which itself has to be less than or equal to b. The question here is find A and B. So pause the video, write down your values, and come back. This question is basically making sure that you don't do extrapolation and that you do interpolation only. So what that means is that our y can't be outside of the y range of data. So y's got to be between these two numbers. And you can look on our data set, the smallest y is 2, the biggest y is 9. So my A has to be 2 because y has to be bigger than 2, and my B has to be the 9 because the y has to be less than or equal to 9. Now that you've watched the video, take a minute to jot down some notes, some questions, or a quick summary of the lesson. You can also re-watch portions of the video that were a little bit challenging the first time. If you enjoyed the video, please click like. And if you'd like to help me grow my YouTube channel, please click subscribe.